Imagine you are somewhere in the dark between stars. You are not on a planet. You are not in a spacecraft. You are simply suspended in the vast, almost empty corridor that separates one solar system from the next. Around you, in the absolute black, things are moving. Not many. They are far apart, scattered across distances so wide that you would never see two of them in the same lifetime. But they are out there. Small fragments of stone and ice drifting through the interstellar gulf at speeds that would feel sluggish on Earth and unfathomable when measured against the distances they have to cross. Some have been traveling for millions of years. A few, possibly, for billions. They came from other stars. They will reach other stars. They are, in every meaningful sense, the small pieces that the galaxy sends back and forth across itself. For most of human history, we did not know they existed. We assumed our solar system was its own quiet enclosure. The sun, the planets, the dust between them. Nothing arriving, nothing leaving. We were wrong. 3 of them have passed through our solar system in the last 8 years. And the most recent has changed what we thought we knew. This is the story of how we found out. Pick one of them, any one. Now follow it backward. The object stops drifting forward. Time begins to run in reverse. You watch it move slowly back across the empty space it has already crossed. The dust trail it shed gradually recondensing onto its surface, the angle of its trajectory tightening as it retraces its way toward wherever it came from. It takes hundreds of thousands of years just to leave the outer edge of our cosmic neighborhood. Then comes the long part. Millions of years drifting through what we call the interstellar medium, a thin haze of hydrogen atoms and microscopic dust that fills the gaps between solar systems. The object is barely affected by any of it. It passes through clouds it never registers, past stars it never sees, through the slow, ancient currents of the galaxy itself. Eventually, after a journey that may have taken longer than the entire history of mammals on Earth, you arrive somewhere. The destination is a star system. But it is not necessarily a star system that still exists. The star this object came from may have died billions of years ago. It may have become a white dwarf, cooling silently in the dark for ages. It may have swelled into a red giant and shed its outer layers across light years. It may have, depending on its mass, ended in a supernova that scattered every atom of itself into the surrounding galaxy. Whatever it was, it is unlikely to be the same star it once was. The world where this particular object may have formed could be long gone. The chemistry that produced it would have dispersed. The system that ejected it, if it still exists in any recognizable form, would have changed beyond recognition. But the object itself survived. A small fragment of a possibly vanished place, carrying, in its frozen interior, a chemical record of where it began and a clock that has been running ever since. If you could see the environment where it actually formed, you would likely barely recognize it. Possibly a young, hot region around an early generation star. A disk of gas and grain surrounding it, slowly accreting into pebbles, then into mountains, then into something more. The mix of elements would have been different than what built the Earth. Poorer in some heavy metals, richer in others, depending on which stars in that ancient neighborhood had already lived and died to seed the gas. It was forged in that environment, from dust to grain to pebble to a body the size of a small mountain. And then, somehow, it was thrown out. A larger planet's gravity, perhaps. A close pass with a sibling object. A slow gravitational drift over millions of years that finally accumulated enough energy to push it past escape velocity. It left its star. It entered the dark. It drifted for what may have been billions of years. If the oldest estimates are right, the journey began before the sun did. The yellow star that the object would eventually cross had not yet ignited. The cloud of hydrogen and dust that would one day become our solar system was still drifting somewhere else, waiting. That yellow star, when it finally appeared, became ours. We have caught 3 of them, 3 fragments in the last 8 years, on hyperbolic paths through our solar system. The first one arrived in 2017, the second in 2019, the third in 2025. Each stayed for only a few months before continuing on toward whatever comes next. None of them slowed for us. None of them changed direction. None of them were aimed at us. They are pieces in transit. The galaxy is full of them, but each one carried information. And of the 3, the most recent has revealed the most. The first was named Oumuamua, a Hawaiian word that roughly translates to a scout from the past, reaching out. It was detected by Pan-STARRS, the survey telescope on the Hawaiian volcano Haleakala. It was elongated, possibly 10 times longer than it was wide. It tumbled as it moved. It accelerated as it left the sun in a way that resembled a comet, but it produced no visible tail. Avi Loeb, then the chair of Harvard's astronomy department, argued the simplest explanation for the data was that Oumuamua might be a piece of alien technology. The debate has never fully ended. The second was named 2I/Borisov, after the amateur astronomer in Crimea who detected it in August of 2019. Borisov was unremarkable in its behavior. It had a coma. It had a tail. It outgassed in the standard way comets outgas when they warm. What was extraordinary about it was simply that it had come from somewhere else. The third was discovered on July 1st of 2025 by the Atlas Surveys telescope in Rio Hurtado, Chile. It was named 3I/Atlas, and of the 3, it is the one that has changed what we thought we knew. In December of 2025, the James Webb Space Telescope spent 71 minutes observing 3I/Atlas as it moved through the inner solar system. What it saw was unlike anything we have measured in any comet from our own neighborhood. The coma was dominated by carbon dioxide. The ratio of CO2 to water was far higher than any typical solar system comet. As sunlight warmed the surface, 3I/Atlas released methane in surprising concentrations and trace amounts of metals, nickel and iron, vaporizing off the body and showing up in the spectra. The atoms themselves, the isotopes of carbon, nitrogen and hydrogen, carried a chemical accent unlike anything from our region of the galaxy. And the chemical signature pointed to an extraordinary age. Recent analyses suggest 3I/Atlas may have formed 10 to 12 billion years ago, possibly before our own sun existed at all. We may have just observed a relic from a planet-forming environment that predates our entire solar system. A small fragment of a world that took shape when the universe itself was less than a quarter of its current age. A traveler, older than the star whose light we briefly watched fall on it. The galaxy has been sending material through our neighborhood for as long as our neighborhood has existed. Pieces of other stars, dust from other planets, fragments of worlds that formed and died and broke apart while our own sun was still a cold cloud of hydrogen. Not yet anything at all. We did not know. For thousands of years of human astronomy, we assumed we were alone in a quiet corner. Now, in the last 8 years, we have learned that the strangers were always passing through. We just had not learned how to see them. There will be a 4th. There will be a 5th. The galaxy will keep sending them, and we will be here, watching the sky, knowing now that some of what we see was born around stars older than our own.